So I'm going to do this problem in a few parts. This is a long problem. So the first step is to actually line up, take your equations. This is actually the same problem we had before. It's actually not number one on your WebAssign. I just had my numbers changed from the previous WebAssign to this WebAssign. And so I just, I didn't want to recreate the whole thing. So this is where I ended up on number one before. You are asked in this problem to set this dynamical system up as a matrix vector form. This is a good time to learn what this is. So what's going on here is that you have W sub n and R sub n. You're going to place that into an array, and we're going to call that P sub n with an arrow over it, meaning that it's a vector. This is reminiscent of your DDS, your one-dimensional DDS, where we called it P sub n without an arrow. It's now an arrow because I have two components. So that is grouped up to be P sub n. Now, this square part here is my equations. If I set these components equal, if I put those equations into an array and I set the components equal, W sub n is equal to this first component and R sub n is equal to the second component. I just line them up. Now I'm going to do something that's funky. It's going to appear like I factored out the W sub n minus 1 and R sub n minus 1, but it's actually just it's a matrix multiplication, because if I go backwards and I take the first row dot the first column, I get 0.9 times W sub n minus 1, which is the first term, plus 0.55 times Rn minus 1, which is the second term. I'll do the same thing to the second equation, the second row. Second row dot first column gives me the second component. And I thought I had this written out. I probably did and somehow deleted it. But I'm going to get exactly 0.10 times Wn minus 1 plus 0 times Rn minus 1 and get the second equation. So this is just a new representation of what you had before. This matrix here is called the coefficient matrix for the linear DDS, the system of linear DDS. And if you look here to the side, this is just the same thing as P sub n, but just knocked down by 1. It's actually the vector P sub n minus 1. So we rewrite it in this form. It looks awfully like what we started out with on day one. P sub n is equal to little a times P sub n minus 1. That's on purpose, because I'm going to use all the same language for a box that I used to use for just a letter. And that box is 0.90, 0.55, 0.10, 0. It's more complicated than that, but all the machinery has been developed already. As a mathematician, I don't like to recreate things because I already told you mathematicians are lazy. So we don't want to do it again. We want to find a slick way to just borrow whatever we did before and apply it here. So I'm going to stop this portion here. This is just setting it up as a linear system. And your P sub 0, I think they wanted P sub 0 in there as well. Your P sub 0 is the vector 80, 0. So what your initial conditions were in array format.